Good morning.
Good morning, sir.
Namaste
Good
and
morning,
vanakkam.
sir.
Namaste and vanakkam again. Yeah. Thank you. We'll continue from where we left off yesterday. So we have discussed two things in this part of the course. First, the idea of data, what constitutes data, the forms of data, and so on. And yesterday we discussed about the scales of measurement, because data and measurement go hand in hand. I mean, there's no point in talking about data without some form of measurement. So we discussed about 4 scales of measurement. Okay? A scale is a concept in our mind, basically. Of course, you could have a physical foot ruler also used as a scale. We refer to it as a scale, So in school, we are asked, where is your scale? So scale actually means foot ruler in that context. But as a scale exists as a concept in our mind. Okay? It has calibrations. And these calibrations are used for the measurement. So what is it that we measure? We measure the level of an attribute belonging to an entity. Okay? There are physical entities and conceptual entities, and we refer to levels of attributes possessed by the concerned entity. Okay? So the entity can even be a concept. Okay? I'll explain this very briefly. If you consider mathematics as a subject, okay, and within mathematics, I'm sure all of us can relate to some amount of math that we have studied in our undergraduate programs. Okay. I will ask a question and I would request you to respond. Which topic in mathematics did you find most difficult? Anybody?
Vector calculus.
Vector calculus. Anybody else?
Probability, sir.
Probability. Okay. I have at least 2 answers. Okay. Which topic did you find easy and you could relate to it well? You can answer.
Linear algebra.
Linear algebra.
Linear algebra. Anything else? Any other answer other than linear algebra? What about basic calculus, analytical geometry? Because
It's easy.
I have only, I heard only linear algebra. That's why I'm asking for any other topic. Okay. Now, how did you find discussions on complex variables? I'm sure all of you would have studied at least one course on complex variables.
It's easy.
Between linear algebra and the other end, what you had said, what was that?
Vector calculus.
Probability.
And vector calculus, So, where would you place complex variables?
In the easy side, linear algebra side.
Closer to linear algebra. Okay.
Yeah.
Where will you place differential equations?
It's all.
You classify that in the set
easy.
of easy. Okay. You might not have done something on topography and graph theory, combinatorics. Did you do any discrete math?
No, for mechanical.
Combinatorics you would have studied a little bit. Okay. Graph theory?
Yes, sir.
It's
those who would have done electrical electronics, I believe, would have had some exposure to graph theory.
Yes, sir.
We did graph theory.
Okay. So, do you agree that it's possible for us to place these topics in math on a scale, conceptual scale, where the scale goes from 0 to most difficult?
Yes, sir.
Correct.
Yes, sir.
Okay, good. So, I gave this example only for us to reinforce in our minds the idea of a scale. Okay, we're ranging from not at all difficult, absolutely easy, to most difficult. Okay. Now, what scale do you think this is among the 4 scales that we discussed yesterday? What do you think is this scale? Is it nominal, ordinal, interval, or ratio?
Ratio.
Are you sure?
Ordinal.
I mean, sir,
Yeah, who said ordinal?
Rishabh.
Rishabh, you're right actually. It's an ordinal scale. Okay? Ratio is the highest form of measurement. Please understand, if you had used ratio scale, it means that you're considering some subject as twice or thrice more difficult than another subject. Well, you can do that as an individual, but it's very difficult to establish commonality across students. I hope you understand that difficulty. I can always claim, this subject was 10 times more difficult than something. But what you actually mean is the order of difficulty and not exactly the 10 times. The 10 times is only figurative. It just conveys your feeling of difficulty. Okay. So please understand, it's an ordinal scale. So we discussed about scales. I gave this example to help you reinforce the idea of existence of scales in our mind. We have the scales. We operate them almost on a daily basis. You operate them in different situations and different contexts. Okay. So what is the scale? Nothing. It helps us get the measure through a measurement transformation. Okay. So you have an entity possessing attributes. You want to know the level of the attribute across several entities, and you make a transformation to a unique point in the scale, corresponding scale. Each level of attribute to a unique point. Okay. Level of attribute cannot go to 2 points on the scale. That's not right. Okay. It's almost like our definition of a function in our discussions early on in math. You define a function, and so on, domain and range and so on. Okay, fine. We studied the scales: nominal scale, which is meant for identity; ordinal scale, which is meant for relative positioning; interval scale, which goes beyond relative positioning, giving you differences; and then ratio scale, which gives you ratios. Okay, how many times more or less something is compared to another thing. So now we come into our first part of data analysis, which broadly comes under the field or under the topic, if I may use the term topic, of exploratory data analysis. Okay, it's a fantastic field, and there is some very good work done by one Professor Tukey, Tukey. He's very well known for his work in this area, exploratory data analysis. Okay, and there's a lot of emphasis on graphical representation in exploratory data analysis. Incidentally, many volumes have been written on exploratory data analysis. Okay, and we are going to see some parts of some very useful, simple parts of exploratory data analysis. We will start with nominal and ordinal data. Now, do you recall something I told about nominal and ordinal data? What you can do, what you should not do or cannot do? Do you recall that? What is it that you cannot do with nominal or ordinal data?
Arithmetic operations.
Yeah, we cannot perform arithmetic operations. I did give you that example. All of you will remember. You can't add 2 ID numbers of 2 students and get a third ID number, which may actually be valid, but there's no meaning in it. Okay, there's no fundamental meaning in that addition. Okay, but what is it that you can do with nominal and ordinal data?
Counting.
Counting. You recall I used the word frequency of occurrence. Counting or frequency of occurrence of something. I mentioned this yesterday, right? Now, when you count, now in the x-axis, what will you calibrate? What will the calibrations be on the x-axis when you use nominal or ordinal data? Very simple. Y-axis is the count, number of times something is occurring, or frequency of occurrence. So on the x-axis, what will the calibrations signify?
the names, the data
Absolutely.
points.
The nominal part, the names, because even in ordinal scales, remember, they only position the names in an order, which must not be violated. Ordinal scale, we must not violate the order. Okay, and I talked of naturally occurring order, not pseudo order. Although pseudo order is acceptable, like I mentioned the example of placing all the countries in the world alphabetically. It's not a natural order, you know. So that is something which we must understand. Okay? And how do we represent nominal or ordinal data and ordinal data? The simplest graphical representation of nominal and ordinal data is in the form of bar charts. Okay, all of you would have seen bar charts, and you can have anything on the y-axis. I'll just draw a simple bar chart in a few seconds, and then you'll understand this. Y-axis is a count of something, and let's say this is countries. Okay, and here you have arranged different countries. So maybe India, and this may be, say, Bhutan. Let's say this may be Mexico, and so on. Some variable, I mean, some context I'm putting this, let's say, placing these countries. In a bar chart, it depends on what the y-axis is. Okay. Let us say the y-axis is population. Now, population is a count, number of people. So I might mark India as something like this. I may mark Bhutan as this, and I may mark Mexico like this. Now, this is a very simple bar chart representation, which is the vertical bar chart. Nothing great to know, but there are some points which you must bear in mind while constructing bar charts. So, first lesson for you, if you notice that you are dealing with nominal or ordinal scale data and you wish to represent it graphically, bar charts, to represent the scores, the frequencies, the counts. Okay. Have you understood this very simple representation?
Yes, sir.
Nothing great
Yes, sir.
to understand. I know you must be laughing. What is LSD asking? What is that to understand in this? So, but it's all right. But there are some things you have to bear in mind, which are conventions. Okay. Are the bars touching each other?
No, sir.
No.
Please note, this is a convention. The moment you are dealing with nominal or ordinal scale data and you wish to portray them using bar charts, ensure that the bars don't touch each other across the x-axis. Okay. But within a bar, I can do something. Okay. Now let me change this a bit. Okay. Suppose I want to portray the male and female populations. I can have bar charts that touch something like this. This is male and this is female. Likewise, I can do for Bhutan also. This is male and this is female. And for Mexico, okay, this is male and this is female. Now you might ask a question, by the way, sir, why have you given such a difference in the case of India for male and female? Incidentally, you must understand that in demographics, what's called sex ratio, male to female ratio, is skewed more towards males. Please understand, India has to do, our country has to do much better in terms of this ratio. No, we need more women in the population. We don't have. In fact, in some states of India, if I'm not mistaken, it is somewhere near 760, 770 women to 1,000 men. I hope I'm not wrong in my data. You can verify and tell me, but I do recall it was as low as that in some states. Okay. And very often you would like something like 960 to women to 1,000 men. You may prefer that. So you know how low it had gone. Maybe I was wrong in my data. Please check and tell me. Male-female ratio, Indian population, state-wise. You can Google and tell me. Okay? Parallelly, you can do that. Somebody can do that parallelly and point out which state has the lowest male to female ratio. Okay, please do that. It's very interesting. But the point I'm making is this. When you present this kind of a graph, okay, What insights can the reader gain from that graph? You may answer me. What do you observe from the graph? Other than the patterns, is there some lesson you're getting out of the graph? Go ahead, please.
Uh,
Yeah,
what, is there India has lowest out of three India has lowest sex sex ratio.
female, I mean,
Yeah.
actually highest. Male to female means highest. Correct?
Yeah, male to female.
Yeah.
Yes, sir.
Correct? Now, do you agree I can replace this x-axis with IIT Madras, IIT Bombay? I'm just giving you an example. Don't take me absolutely literally. Okay? IIT Madras, IIT Bombay, IIT Delhi. Can I do that or not?
Yes, sir.
Yeah.
Of course, with the appropriate numbers on the y-axis. Can I draw a plot of that or not? Number of male students to female students in each institution.
Yes.
Yeah. So you understand, no? The basic representation of nominal or ordinal scale data and its and the effectiveness of portraying graphically in the form of bar charts. This kind of a bar, in fact, I didn't draw the line. I should draw this line. This kind of a bar is called side stacked bar chart. And what is important for us to note is when we want to make these kind of comparisons within a nominal item, so you use side stacked bar charts. I'm sharing some conventions with you, simple conventions. Okay. Also, have you come across bar charts like this? Have you come across bar charts like this? What are known as vertically stacked bar charts?
Yes, sir.
I'm just saying this is product, agricultural product, India, rice, wheat, maize, yield percentage. Or how much is produced basically in terms of percentages. This is called a vertically stacked bar chart and you could compare other countries. For example, I can compare China, China may be something like this. So I say China. And then I say rice, maize, rice. I may be wrong, but I'm just giving you a small example. Maybe China. Okay. Is this clear?
Shouldn't their heights be similar?
Not
100%.
necessary, no. Oh, sorry. You're right, because I said percentage. Okay. Suppose I don't take percentage, but have some other absolute measure. You're right. Whoever pointed out is correct. I'm very sorry I made that mistake. Okay. You're right. Because if it's 100%, then it should be same height. It's very, very correct. Okay. So I'd say rice, maize, and wheat. Thank you for pointing out. The moment I switched off. What is that? I think who was that person who used the famous term brain fade in cricket? Was it Steve Smith of Australia? Okay.
Yes, sir.
Yeah, Mohan Raj, thank you. Anyway, that was a small brain fade. I beg your pardon. So it should be the same because it's 100. If I use percentage, it should be 100. All of them will be same, but the proportions will vary. Now, in these two plots or in these two graphs, what comment can you make from your observation? You're observing something. Can you make some inference beyond your observation? All of us are observing I would argue that all of us are observing the same thing. But are we doing the same analysis with what we observe? I'm sure that our analysis is going to be different. So what is the result of your analysis? What do you go and what do you think beyond your observation? You can take either graph and tell me. First level, what do you observe from that yield percentage, product and yield percentage, vertically stacked bar chart? Yes? At least first let's start. What is your observation? Obviously you're observing something. What is your observation from the vertically stacked bar chart?
Rice is produced more in China.
Okay, that's the
In-
first observation. Then okay, I know I'm prodding you a little bit, but this is interesting. This is where you start diving a little bit into interpreting the graphs. Okay. Can you make some assumptions out of this bar chart representation, the vertically stacked bar chart representation? By the way, we are talking about data analysis. So we have to go beyond data representation. What I've done is represent the data graphically. Now can we do some analysis? You made a straight observation. There's a greater proportion of rice production in all agricultural products in the plot in China compared to India. Okay, correct. That's an observation. Can you come up with any related assumption? Okay, let me help you in the context of import, export of agricultural products. Can you make an assumption? By the way, I'm not talking of an inference. I'm talking of an assumption.
China exports more rice, maybe.
China is?
Exports more rice.
Okay, fine. Is that an assumption you will make?
Assumption can be that China consumes more rice. I mean, cannot be. I think I cannot derive that inference.
So, yeah, that's a fair one, Arvind. If you say, obviously, China produces more rice, therefore, I would ordinarily expect greater consumption of rice in China. Not a bad inference, actually. It's not a bad inference. It's an inference. Assumption I am saying is, shall we make an assumption that we are going to be concerned with this graphical representation in the context of in-country consumption? Can we make that assumption that this graphical representation is also related to the within-country consumption of those products? Have you understood the assumption?
So we can assume that.
Yeah, it's an assumption. We can't, obviously at this time, we cannot assert that it is true. But it's not a bad assumption that these proportions reflect the eating habits of people indirectly. We can say that China and India are larger consumers of rice. Okay. And we can also make an observation that China consumes less wheat than India. Okay. That's an observation in terms of production, and then you draw an inference. So do you agree that it conveys something about the eating habits or the diet, the nutrition of people when you look at this graph? Can we make those inferences?
Yes, sir.
So we can go one step further. We say that, look, these countries are carbohydrate rich diet countries. Correct?
Yes, sir.
So such inferences you can start drawing from the plot. You see the power of the plot. Okay. So graphical representations are extremely useful from that perspective, from that point of view. I hope you appreciate that. You might be wondering what's there in a bar chart, and from our discussions now, you can understand there's a lot you can gain from a graphical representation. Readers can actually understand many points, and if they're very sharp and intelligent, they can quickly make assumptions and inferences also. Okay? We are not talking of right and wrong here, we are talking of that act of analysis, the analysis of graphically presented data. Okay? Right and wrong comes later. Whether the assumption is a strong assumption, is a robust assumption, or is it a weak one or a wrong one, comes later. Because you have to verify the data that's given. Likewise for the inference also, it's not, it's quite possible that somebody may be making a wrong inference from the graphical presentation. Okay, we can't say it is not likely. It is likely that people may make mistakes, but that sort of conveys to you the idea of analysis of graphically presented data. Okay, so we talked of side stacked bars, vertically stacked bars, and so on. Yeah, in fact, I would like you to visit some graphical representations through different websites and portals, and you'll find some amazing representations. As I told you a little while ago, this entire subject of exploratory data analysis is, to me, it's very fascinating. We see some of the early developments marking certain plots, of how armies moved from one country to another, and showing the time on the x-axis and the size of the army on the y-axis, and what events caused a certain outcome in the whole journey of the army from one place to another. It's very fascinating. A whole story unfolds from that. So exploratory data analysis is, at least according to me, truly fascinating. There is so much you put in a picture, and that is why people say a picture is worth more than 1,000 words. I think now you can understand. Okay? Now comes an important point. There are some other conventions. If the maximum count in a bar chart is more than 3 times of the minimum count in that bar chart, then you shift from a portrait bar chart to a landscape bar chart. Do all of you understand what's meant by landscape bar chart?
Yes, sir.
So in a landscape bar chart, what will the bars look like? Will they be vertical or will they be horizontal?
Horizontal, sir.
Horizontal.
Absolutely. Okay. So in a landscape bar chart, the bars will be horizontal. Again, you can have side stacked or vertically stacked. Okay. There is also another kind of bar chart which is called the opposing bar chart. This is typically used to represent population distributions age group wise. So I'm going to show you one. Okay. This refers to population. By the way, the left side does not signify negative. So I'm going to write here negative side cross. I hope you understood this. The left side does not mean negative, quite unlike our ordinary or typical practices. The moment you go to the left side, we ordinarily think it's negative. In this case, it does not signify negative. Please note that. Now comes this is age groups. Okay. So we'll come to this. So this side will be male, this side will be female. I'm using our convention. It's almost like our Ardhanarishwara convention. Okay, male, female in the same body. Male on the right side and female on the left side. Okay. So Now this age group is, let's say, 0 to 5 years. 0 signifies just born, in that sense. 0 doesn't mean yet to be born or not born. That's not the meaning here. And then I will have another bar chart here showing something like this. So this may be, I'll also define this very precisely. Greater than 0, which means 2, less than or equal to 5. And this one may be greater than 5 to less than or equal to 10. Sorry. 2 less than or equal to 10. Do you agree I can construct this across age groups? Can we do that?
Yes, sir.
Across age groups, we can construct that plot. Please refer to population charts. Just go to Google and ask for country-wise population charts. And they will tell you something very fascinating. Very, very fascinating. And I would like you to look at particularly India and China, the population distribution presentations, graphical presentations in this form. Sometimes people refer to it as the population pyramid. It's just that it's possible that you might actually not have a pyramid. You may have some different shapes that happen when you construct it fully across all the age groups, even going up to 120 if you wish. I believe there's nobody living beyond 120 or maybe 110. You can imagine, can you, even without going to Google, can you tell me what will be the shape of India's population pyramid? By the way, this is a graphical presentation of data. The data is count of people in these age groups in India. I've not written India here. You can sort of make that note that I'm referring to India. Come on, our own country. What do you think is the likely shape of that whole graph if it would have been developed completely?
It's a triangle.
A sort of triangle. That means you're saying that the proportion of old people is much lower compared to the proportion of much younger people. Is that correct?
Yes, sir.
Okay. Now, I would suspect, by the way, I've not seen this plot for India in a long time. Okay. But I would suspect if somebody plots, you might have fewer children, a little more people from the age group of, let's say, 15 to 50. Just if somebody can Google check and tell me, this should take you a few seconds, that's all, not more. Just Google and ask for India's population pyramid. Have you done it? Hey, guys, I think you have your phones with you. Rishabh Bhai,
Yes,
do you
sir.
have your
Sir,
phone
yes,
with
sir.
you?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So,
Sir, it's sort of triangle only, sir.
is it a triangle?
Yes,
That
sir.
means there are more children than adults and elderly people.
Yes, sir. Yes, sir.
Yes, sir.
But what date does it correspond to, Dushyant?
So fertility rate is declining, so I think it would be a little heavy in the middle.
Arvind, that was my guess, Arvind. In fact, that's what I was guessing. By the way, all of you would have come across this term, no? India is going to reap the demographic dividend. And then there have been debates on this. Is it a demographic dividend or a demographic disaster? So people are debating, there's a lot. And I am aware of some of the arguments. If you ask me my opinion, I will only say I don't know. And I know that I don't know. It's very difficult because the arguments cut both ways, Of course, I can make some observations and comments, but outside our course, I won't do it in our course. There are many things to do with population the morals and ethics and character of people in India, what is visible, etc. All these things matter, whether something is a dividend or a disaster. Okay, so we will talk about that. But you got the idea. And anyway, it's all right. I'm happy that you saw that. But can you, without going to Google, can you tell me what is the expected figure for China? By the way, we are talking of graphical representation of data, but I'm taking you through these discussions just to enthuse you about the kind of analysis that can be done. Can you share your expectation of what you think the China's figure will look like? The graphical representation will look like.
So thicker towards the end.
Thicker on the top, correct?
Yes, yes, sir.
Or instead of thicker, Arvind, shall we say wider on the top?
Yes, sir, wider, right.
Yeah, wider on the top and narrower in the middle and the bottom.
Yes,
That's
sir. And
actually true, Arvind, if you check, because China is now reaping the consequences of the what you call as child emperor policy. I mean, it's not a child emperor policy, single child policy. So it came to a social phenomenon called the child emperor, you know, in the families in China. Because China was enforcing single child policy, but you know, demographic phenomena have an effect after time. So since they did that, now they are reaping the consequence in the form of a larger proportion of relatively aged people. So you have you see the kind of inferences that we can draw. If you go to social psychology, okay, at least I'm not a scholar in that, but I've had friends in that specialization who have shared with me something very interesting. They say that in a society where a small proportion of the population, namely the younger working group population, supporting a very large proportion of aged people, could have some social imbalances, which I think can appeal to our minds. Imagine a very small proportion of working age population relative to a very large proportion of aged people who are being supported by this. Now you can understand the psychology of the people in the families, you know. So in fact, even in India, why India? In Chennai, in a home that I know very well, I am aware of a person who comes and helps. He's a male, where his son has told him, if you bring in 5,000 rupees per month, I will give you food. Otherwise, get out of my home. Okay. See, there are many such phenomena that happen. I'm not saying all homes are like that. Please don't extrapolate into all homes. I'm only talking of a phenomenon, a social phenomenon. I hope you are seeing the value of making such observations and inferences from the graphical presentations. Are you finding that interesting, please? I'm not asking you a loaded question. You can answer straight away. Okay. At least it's very interesting to me when I see these graphs, you know. Because you go beyond the graph. You're like a Sherlock Holmes, you know. You're trying to be a detective and you're trying to make some useful inferences from the graphical representations. Okay, that's the value. Now, I hope you got all the conventions in bar charts. Bars will not touch each other. The counts will be either on the x-axis or the y-axis, depending on whether you wish to have the portrait form of representation or the landscape form of representation. Now, when do you move to the landscape form of representation? Bar charts. If the maximum count of any nominal category on the axis is 3 or more times than the minimum nominal label in that axis, you go for a landscape rather than a vertical. Now you might ask, but LSG sir, why is this change happening? See, this has to do with a lot of analysis people have done, and they know that the mind processes these graphs in a certain way. So they've done some experiments and checked on the comfort in terms of observation and analysis on a landscape presentation and on a portrait presentation with varying scales and counts. Okay, and then they come to this suggestion that please, when you are dealing with situations like max is 3 times or greater than min, then please go for a landscape. This is one point. I haven't mentioned another point to you, and this I've noticed, and I've also seen a couple of articles earlier, okay, general articles. Color combinations matter hell of a lot. Is it necessary that all of them will be only in black and white?
No.
So color combinations which you use can have an effect on the reader or the viewer of the graph. I hope you're noting this point. Now this leads to a very interesting insight about graphical presentations, and you will like this. All the students I've taught earlier have said, LSG, this is a nice point. What is that point? The graphical presentation has a purpose larger than the graph itself. Now you might wonder, what is that larger purpose? The purpose is to make the viewer see and understand what you want him or her to see and understand. I repeat, the fundamental purpose of graphical representation beyond the graph is to convey a certain image to the viewer or the reader and make that person, he or she, observe and understand the way you want him to observe and understand. So you're
Yes, sir.
sort of, yeah, go ahead.
Sir, sir. Sir,
Arvind?
I see the point, sir. Yes, sir.
Yeah, good. Thank you, Arvind. It's a very interesting point. In some sense, you're trying to remove the individuality out of the viewer and imposing your presence into the mind of the viewer. By the way, it's a very strong point, and please understand, graphical presentations have been discussed by quite a few authors, and there are many distortions that can be made in graphical presentation where the viewer is actually processing only the graph and not going behind into the message of the graph. And because many viewers process only the graph, you take advantage of that and can distort what's happening, sometimes unethically also. I hope you've noted this point. Please make a special note. So never underestimate the power of graphical representation. We might all have seen many graphical representations in our magazines and sometimes newspapers, etc. But today's interactions will hopefully help you understand those graphs, or those you will see henceforth, in a different way, not the same way you've done earlier. So whenever you see graphs, understand what is the scale on the x-axis or the main axis or the domain axis. What is the scale? Nominal, ordinal, interval, ratio. Nominal and ordinal, I've given you the convention. It will be a bar chart if you're talking of counts, and the bars won't touch, except in the case of side stacked and vertically stacked. And of course, like this, opposing bar charts. I told you why they are drawn, typically to show population pyramids. Color combinations. Please understand, color combinations do something in your subconscious mind. Your subconscious mind works in a certain way, and we will not know our subconscious mind. We won't know it, but it's doing something. And my friends in psychology have often shared with me that the subconscious mind is a stronger driver of human behavior than the conscious mind. By the way, look at the connections that are happening. So I can portray a graph. Of course, you may ask, what do you mean, sir, if we cannot understand the subconscious mind, what the hell are we talking about drawing a graph? The point is this: do you agree that we are able to observe certain fundamental characteristics, behavioral patterns in other people that we are also observing that they are not observing themselves? Is that true or not?
Yes, sir.
Have you understood the point I'm making? Do you agree that all of us have blind spots in us? That is, aspects of our personality that we don't observe in ourselves. Is this true or not?
Yes, sir.
Do you agree we have mental models or images of others?
Yes, sir.
And do you agree that those mental models may contain some thoughts that pertain to the behavior of that other person, which the other person is not observing?
Yes, sir.
I will give you examples. When you come to the subject of management, one of the interesting behavioral patterns in management is micromanagement. You would have come across this term micromanagement. Have you? So can I assume that you have not come across this term micromanagement? Come on, guys.
No, sir.
Okay, fine. Now, what is micromanagement? It typically happens even in our homes sometimes. So I'm just imagining and giving you an instance. Okay, it's an imaginary instance. So I'm there and I'm, let's say, observing my child doing something. Okay, let's say my child is putting her hand on the nose. If I'm a micromanager, why are you putting, I'm exaggerating, but you will understand the point. Why are you putting your hand on your nose? Oh, no, Appa. No, I'm sorry. No, you just put your hand on the nose. Why did you take down your hand? Why are you not looking at me? Every damn move of my child, I want to manage. Have you understood?
Yes, sir.
Yeah, that's micromanagement. Now you can understand this is not uncommon in work situations, professional work situations. You'll have managers literally screaming at every damn move of their subordinates. And the subordinates, while having tea or what you call the water cooler moments, they will be sharing. What is this guy here? He's just getting at my nerves. Every move he is commenting and questioning. Why doesn't he give me my space? All this happens. So this kind of aspects are also there. I shared with you all this because you must know that sometimes we make observations of the subconscious minds of others. May not be our minds, but others, because you see the behavior. It's revealed behavior. Okay. So this is what I meant by that. So you are trying to, in graphical presentations, you are trying to reach out to those aspects in general. Not that you know every subject who is going to read or view the graph. We won't know that. But in general, you're aiming at that point. Am I clear?
Yes, sir.
Okay. So color combinations, these are also important. So we've talked a lot about bar charts today. I'll just finish another point and then we'll close for today. Okay. When you want to represent proportions rather than counts, then you use pie charts. You would have come across these pie charts in many places. Okay. See, suppose I want to represent, let us say, I do a sample study and I want to get the proportion of people who are voting for a party. Let's say Bihar elections are over. Okay, we want to show proportions of people voting for, this is our NDA and this is our RJD.
Sir,
And
actually, we have another class.
Yeah, I'm closing this.
Yes,
I'm
sir.
closing this, just a few seconds. Here I mark the proportions as sectors in a circle. So for representing proportions, we will use pie charts. So when we meet tomorrow, I'll continue with this. Bye, guys.